Okay, go.
Hello everyone, welcome to, did I say it from there?
Go ahead.
Hello everyone, welcome to our video. Today we're going to be discussing this practice problem that is on the cognity and it's related to angular momentum. So let's get started.
What number is it?
It's what number is it, Charles?
42.
Number 42 on the rotational motion stuff.
The really dark magic assignment.
Oh, that's good. That's smart. Thank you, Nicole. Really dark magic stuff. Okay, so first of all, concepts. Linearly F net. Can you help me? Thank you, Farzan. I need my cameraman. My cameraman is asleep. Thank you. F net is MA, linearly, right? But rotationally, that means the net torque is equal to I, which is moment of inertia, times alpha, which is rotational acceleration. So this is all kind of analogous. Rotationally, mass is like moment of inertia. That's mass is resistance to force, right? Inertia is resistance to rotational force, the moment of inertia. And alpha is just acceleration angularly, so this is radians per second squared instead of meters per second squared. And torque is just like force, but what's the difference between torque and force?
Torque is force times distance root of.
Perfect. Cool, thank you. So this is force times R. So we have this weird situation where there's this spiral cord wrapped around a cylinder, and it's kind of like a wheel if you had a string wrapped around here and the string was pulling the wheel down and some weight was falling. So we've been given the acceleration of the thing that's falling, right? So as the thing falls off the edge, it accelerates downward. That's not the same as rotational acceleration. Nicole picked out that this is tangential acceleration. So it's just the acceleration at the edge, like the linear acceleration. Okay, so they're asking, what's the tension force here in the string? If we knew the mass of this, it would be really easy, which I thought it was for a second. I thought they'd give us this mass, which would be just gravity, tension force, net force, easy, right? But they didn't give us this mass. They give us the mass of the cylinder. Okay, so we need to figure out what the force is on the edge of our cylinder. Thank you, Farzan. So we need the net torque equals moment of inertia times alpha, rotational acceleration. That torque is going to be the tension force times the radius. So the perpendicular force at the edge times the radius to the center. That's our torque, right? So we write that in. Our moment of inertia of a cylinder is half mr squared. If it was just a point mass, what would it be? Correct. It would just be mr squared. But because the mass is filled in right to the center, the average radius is 1/2. So we say it's half mr squared. And then alpha, this takes a little bit of thought. So rotational acceleration is kind of like rotational velocity. So angular velocity is your radians per second. If you multiply that by the radius, you get velocity. Or are we off the screen again? Here, I'll just move it. How's that? So velocity linearly equals rotational velocity times the radius. But only if you're in what unit?
Radius.
Good, radius. Because every time you go through 1 radian, you travel 1 radius of length around the arc, right? So that's true, and acceleration is also equal to alpha rotational acceleration times the radius. Okay, so we've been given our linear acceleration, so we divide the radius down, and we should be able to get our alpha, our rotational acceleration. So that's what we did. We said, okay, alpha is a over r. So we have half mr squared over r, and then we bring this r down underneath, and we end up with r squared over r squared, and we get rid of those ones. So we don't need to know what the radius is, we just know that they're canceled. And then we end up with a tension force equal to the mass of the cylinder times the acceleration at the edge of the cylinder, which is the same as the acceleration of the hanging object as it pulls the rope down. And it's divided by 2, really only because this is a cylinder and not a ring. If this was a ring, there would be no 2 there. And then we just put our numbers in and we get about 0.6. And that's the correct answer of the tension force. So that would be in newtons, right? Pushing, this rope would be pulling down on the cylinder and pulling up on this with the same amount. Yes, Nicole?
It smells like gas.
Well, that's not good.
It does.
Fantastic.
Everything's closed, so
Sound like that.
should be okay. Where did walk around and try to find it? This is on video, so
You're alive.
Carbon monoxide. Very safe.
cross your fingers. I hope we're still around.
Charles, you died.
If you're watching this, this means
Upload on live link.